So problem 9 in quadrilateral ABCD, sides A, B, and BC both have length 10, sides CD and DA both have length 17, and the measure of angle ADC is 60 degrees. What is the length of diagonal AC? Choice A, 13.5, choice B, 14, choice C, 15.5, choice D, 17, choice E, 18.5. Leo and Loy, what did you guys get for this? Okay, Loy got B. Leo, do you agree, disagree? Okay, that's fine. Yeah, so Loy, I agree with your answer. That's correct. Do you want to share how you solved this? Do you want to talk about your thought process and your solution? You can feel free to unmute. Not sure if you're typing or okay, you're probably typing. Um, while you're typing, I'll just show the official solution and we'll see if your solution lines up with this or not. So whenever you see a geometry problem, you always want to start by labeling the angles and the side lengths. And so basically you want to start off by labeling the information that you have so that you can easily visualize it, right? So in this case, they're telling you that sides A, B, and B, C both have length 10. So if I were solving this question, I would write 10 here and 10 here. They also tell you that CD and DA also have length 17. So I would write 17 right here. Finally, the measure of angle ADC is 60 degrees. So I would write a little 60 right here. Now, this problem uses two fundamental facts in geometry. And the first fact is that the angles in a triangle add up to 180 degrees, right? You all know this, I'm assuming, right? Given any triangle, all of the angles inside it add up to 180 degrees. And the second fact that this utilizes is that whenever you have an isosceles triangle, two of the angles are always going to be equal. And in other words, in this particular triangle right here, this one, triangle ACD, since side AD and side CD are both equal to 17, that means these two angles must be the same. They have the same angle measurement. So that means what you're going to do is that you're going to subtract 60 degrees from 180, right? Because every triangle's angles add up to 180. You're going to subtract 60 degrees from that to get 120. And then you're going to divide 120 degrees by 2 to get the measurement of the individual angles. So what you end up getting is that these two angles are also 60 degrees. And what that tells you is that you simply use the fact about isosceles triangles again, right? Because, and this is an equilateral triangle, right? 60, 60, 60 is called an equilateral triangle. And an equilateral triangle is simply an isosceles triangle that's isosceles on all three sides. So that means this side must also be 17, right? Because by definition, an equilateral triangle has the same side lengths, same angles. So the answer is D, 17, and Loy, you are absolutely correct. Leo, does this make sense? Joyce, does this make sense? Are there any questions? Going once, going twice. Okay, yeah, and yeah. Okay, great. All right. Let's delete all of this. Okay, problem 10. Joe had walked halfway from home to school when he realized that he was late. He ran the rest of the way to school. He ran 3 times as fast as he walked. Joe took 6 minutes to walk halfway to school. How many minutes did it take Joe to get from home to school? Choice A, 7 minutes. Choice B, 7.3 minutes. Choice C, 7.7 minutes. Choice D, 8 minutes. And choice E, 8.3 minutes. Let's take a vote. Leo and Lloyd, what did you guys get for this question? And if Joyce and Justin, you guys solve this question, you can also go ahead and tell us what you think. Oh yeah, Joyce, that's totally fine. Thank you for letting me know. Yeah. Okay, so Leo votes D. I think Lloyd also voted D. Okay, yeah. So I agree. That's the right answer. And I'm just gonna share with you how I would solve this question. And if you have a different solution, please do unmute yourself and share with the rest of the class. But I will go ahead and show you how I would solve this question. So if you're kind of like, geometrically or like algebraically challenged, then sometimes drawing a diagram might help, right? And what you do is that you take a straight line and you put this as his home and you put this as his school, right? So I'm gonna write a little H here for home, a little S here for school. And it says that he went halfway to the school when he started running, and that took 6 minutes, right? And then after he got to this halfway point, he started running. But since he runs 3 times as fast as he walks, that means that if it takes 6 minutes for him to walk half the distance, then it would only take 6 divided by 3 equals 2 minutes to run that same distance. And finally, you add these up and you get 8 minutes. And so the answer is D. Honestly, a fairly simple and straightforward question. But are there any questions about this problem? Any comments, any concerns? Going once, going twice, going 3 times. Okay, hopefully relatively simple and hopefully everyone understood this. If not, please let me know. And I'm happy to talk more about the solution. But in that case, let's move on to problem 11. So the sales tax rate in Bergville is 6%. During a sale at the Bergville coat closet, the price of a coat is discounted 20% from its $90 price. Two clerks, Jack and Jill, calculate the bill independently. Jack brings up $90 and adds 6% sales tax and subtracts 20% from this total. Jill brings up $90, subtracts 20% of the price, and then adds the 6% of the discounted price for sales tax. So basically, the order that they did this was a little different. And so, what is Jack's total minus Jill's total? Choice A, negative $1.06. Choice B, negative $0.53. Choice C, 0. Choice D, $0.53. And finally, you have choice E, which is $1.06. Um, go ahead. What did you guys get for this question? Lois is C. Okay. Leo, were you able to solve this question or were you stuck on this? Okay. I'm assuming that you were a little stuck. So this question looks really wordy and really complicated, but in reality, it's actually the simplest question on the test because it's really just using the multiplicative commutative property, right? And what this property says is that in multiplication, it doesn't matter what order you multiply things in, right? So for example, if you multiply five, oh shoot, if you multiply 5 times 6, you'll get 30. But if you get 6 times 5, you also get 30, right? It's really an intuitive idea, and I'm sure that all of you understand this. But the way that this applies to this question is that when you add a sales tax or subtract from a discount, and basically when you multiply by percentage, what you're really doing is multiplying by a decimal, right? Because say that you add a 6% sales tax, then what you're really doing is that you're multiplying by 1.06, right? Because 1.06 is equivalent to 106%. So if you multiply the original sales price by 1.06, you're multiplying it by 106%, which means that you're adding a 6% sales tax, right? Because you're paying 6% more. And in case you didn't understand why this is true, it's because the percent sign really just moves the decimal point 2 places to the right, right? So 1.06 is exactly the same idea as 106%. It's just different. It's just written differently. And so with that in mind, saw a right, exactly. So with that in mind, if you calculate jacks, you would have jack is 90 times 1.06 times 0.8, right? 0.8 because you're paying 20% less, right? So you're subtracting 20% from the total. So you're actually paying 80% of the total, which is 0.8. But if you look at Jill, what she's doing is that she's multiplying by 0.8 first, and then multiplying by 1.06. And so if you look at these two equations, you'll notice that it's really just an application of the distributive property. I mean, sorry, the commutative property, right? Because it's the same numbers that are being multiplied together. It's just a different order of a multiplication. But again, that doesn't change the answer. So if you subtract this, you would simply get 0, and the answer is C. Does this make sense? Are there any questions about this? Any confusions? Justin, does this make sense? Leo, does this make sense? Do you guys have any questions? Okay, I'm assuming that you guys understand this. And let's look at the last question. So problem 12. Big AI the ape ate 100 delicious yellow bananas from May 1st through May 5th. Each day he ate 6 more bananas than on the previous day. How many delicious bananas did Big AI eat on May 5th? So go ahead, take a vote. What did you guys get for this question? Leo, were you able to solve this one? Okay. D. Oh, okay. Interesting. We have a disagreement here. A and D. Okay. All right. Okay. Do you guys want to share how you solved this question so we can see, like, where one of you went wrong? Does anyone want to volunteer? I would encourage you to unmute. It's a lot faster than typing. Does anyone want to share their solutions? Just raise your hand, like using the emoji thingy. Okay, I guess. All right, so here I'll show you. Oh, it's E. Okay, so you changed their mind. That's fine. Let's see how I would solve this question. All right, so basically this is an arithmetic sequence, right? If you didn't recognize this, this is an arithmetic sequence because you have a common difference between each consecutive term. And well, actually, before we even start this, does anyone here not know what an arithmetic sequence is? Raise your hand if you don't know what it is. If you don't raise your hand, I'm assuming that everyone knows this. Okay, great. So in that case, what I would do is I would simply set the number of bananas big out 8 on May 5th as in. It's an ugly in. And I would set the number of bananas that big out 8 on May 1st as n minus 6, sorry, 4 times 6, right? Because it's 5 days. It's May 5th, so there was 4 consecutive, I guess, differences between them, right? Because each term is 6 more than the previous day. So that means 4 days ago, he ate 24 less. And finally, I would divide this by 2 and multiply by the number of terms and set this equal to 100, right? And this is using the formula for calculating and summing an arithmetic sequence. And finally, if you do the math, you'll get 2n minus 24 is equal to 40. And so n is equal to 32, which is D. So whoever said D earlier, you are correct. Congratulations. Are there any questions about this problem? Any confusions about how I solved it? Does it make sense to everyone? Arithmetic sequences pop up a lot in the NCA, so it's important that you understand this. Okay, I'm assuming that all of you have no questions. All right. In that case, let's move on to the second set of questions. And once again, I'm gonna give you like 10 minutes to work on these. Again, let me know in the chat if you need any help or hints, and I will see you in 10 minutes to discuss these questions. Good luck. So, problem 13, the area of polygon ABCDEF is 52, with AB equals 8, BC equals 9, and FA equals 5. What is DE plus EF? Option A, 7. Option B, 8. Option C, 9. Option D, 10. Option E, 11. So what did we get for this question? Leo got C. Loy also got C. Okay. How about Justin, were you able to solve this question? Okay. All right, so let's jump ahead into, oh, Justin says B. Okay, we have a disagreement. That's okay. Here, let's go ahead and solve this question and see what the answer is. So honestly, this question isn't too bad, right? Like the geometric shape looks really complicated and complex, but it really just boils down to area, right? So if they tell you that the area of the entire thing is 52, but if you notice this, you'll notice that this is a rectangle, right? This shape can be divided into a rectangle and another rectangle that looks like a square, but is probably a rectangle. And right off the bat, you can say that this has an area of 40, right? Because 5 times 8 is 40. And so that means this has to have an area of 12, right? Since the total area is 52. And we know that the area of the big triangle, sorry, the big rectangle is 40. So given that, you also know that the side length here is 4, right? You know that the side length here is 4 because the length of this entire side is 9, given here, and the length of this side is 5. So that means the area that's jutting out of this big rectangle must have a side length of 4, right? So it has a side length of 4, and finally has an area of 12, and it's clearly a rectangle because it has right angles. So that means this has an area, this has a side length of 3, which means that this side here, FE, has a side length of 8, right? Because if this side has a total length of 8, right, because it's opposite side of the other side of a rectangle, so they have the same length, and this here has a side length of 3, then that means this side here must have a side length of 5. And so combining these together, you have that DE plus EF is equal to 9. So the answer would be C. Are there any questions about this problem? No questions? Everyone understands how to solve this question? Going once, going twice, going three times. Okay. All right, then let's move on to the second question. Okay, problem 14. The Little 12 basketball league has 2 divisions with 6 teams in each division. Each team plays each of the other teams in its own division twice, and every team in the other division once. How many games are scheduled? A, 80, B, 96, C, 100, D, 108, E, 192. What did we get for this question? Did anyone solve it? Or does anyone have any questions about it? Okay, Lois says B, as usual, the star in today's class. Did anyone else solve this question? Okay, so let's just go ahead and dive into this. So first of all, I want to ask, does anyone here okay, let's say it this way. Is everyone here familiar with um combinations? Like not just combinations in real life, but combinations in like mathematics and how to calculate combinations. Okay, Lois says yes. Leo, Joyce, Justin, do you guys also understand combinations in math, or would you prefer to have a little crash course or review on it? Okay, Leo understands it. Okay. Justin and Joyce, let me know if you don't understand it, but for now, since I don't have a reply, I'm gonna assume that you guys do understand it. I'm gonna go ahead and solve the question real quick. Okay. So you want to first calculate the number of teams within the 2 own divisions, right? So as it says, each team plays each of the other teams in its own division twice. And so, I mean, first of all, you want to look at how many ways you can pair up 2 teams, right? And that's just a simple combination. You have 6 teams in total for each division. You want to choose 2 of them, right? This represents the total number of possible matches, right? But then it says that for each possible match, you actually play them twice, right? So that means you want to multiply this by 2. But then remember that there's 2 divisions. So you're going to multiply by 2 again. And 6 choose 2, which is this thing right here. That evaluates to 6 times 5 over 2 factorial times 4. And that evaluates to 60. And now for the interdivision teams, interdivision games, you know that for the first team, there's six. For the first division, there's six options. For the second division, there's also six options. So you have a total of 36 possible games. And 60 plus 36 gives you a grand total of 96 games, which is B. Does this make sense to everyone? Are there any questions about this? Especially with the combination here, does everyone understand how these work? If not, I'm happy to give a little quick review because they do show up a lot in the competition. Okay, so I'm assuming that we're good on this. All right, then let's take a look at problem 15. So, how many different isosceles triangles have integer side lengths and perimeter 23? A 2, B 4, C 6, D 9, E 11. What did we give for this question? What is C? Okay. Leo also says C. Okay. Out of curiosity, this is the correct answer. Okay, so you got the answer correct. But did you guys solve this question by counting or did you solve an equation? I mean, both works, but I just want to see if you guys solve this by counting or using like an algebraic manipulation equation. Okay, Lloyd, you use an equation. Do you want to share with us how you set up that equation? Can you annotate on the board and write what you did? Are you able to annotate right now? All right, all right. Okay, then I will go ahead and share how I would solve this question. So obviously you can just count, right? Because isosceles triangles, by definition, one of their sides is unique. I mean, no, by definition, two of their sides are equal, right? So you can just tamper with the third side. So you can, and again, and because it has integer side lengths and a perimeter of 23, you do know that the third side has to be an odd number in order for them to be integer side lengths and for the two sides to be the same. So that means you can have the unique side be 1 and the two other sides would then be 22 divided by 2, 11. You can have, I'm just gonna write it like this. You can have 3, and the other two would be 9 and 9. Wait, sorry, no, that's not right. But 10 and 10 looks like a 16. 10 and 10, you can, oh my God. You can have the third, one of the sides be 3 and the other two be 9 and 9. You can have one of the sides be 7 and the other be 8 and 8. You can have one of the sides be 9 and the other two sides be 7 and 7. And finally, you can have the side be 11 and the other two sides be 6 and 6. Um, yeah, I mean, actually, this is really interesting because if you look at this, this is 20, 22, 23, 23, 23, 16, 23, 14, 23, 12, 23. Right, and so this would give you a total of 6 different options. But you could also try to solve this using an equation. And the way you would do that is you would use the triangle inequality. And the triangle inequality is the idea that in a triangle, any two given sides is greater than the third side, right? And when you say it's greater than third side, what you mean is that you start off by writing 2a plus b equals 23, right? Because it's an isosceles triangle, and you want to make sure that it has two sides with the same length, right? So you want to have a 2a to represent that and a b to represent the third side. But then what you do is that you set up a new equation, right? Because these 2a will always be greater than b, right? So what you do is you solve for 2a, you get 23 minus b. And by definition, because 2a is greater than b, you have that b, oh wait, no, sorry. You have, actually, I think a better way to write this would be b equals 23 minus 2a. And then since 2a is greater than b, you have 2a is greater than 23 minus 2a. You can then solve for a to get a is greater than 23 over 4. And that's roughly, I think, 5.75, if I'm not wrong. And so you know that a has to be greater than 5.75, but at the same time, you also know that a has to be less than 11, right? So in that case, you really have a total of 6 options, right? You have a equals 6, 7, 8, 9, 10, and 11. And so that gives you a total of 6 options. So the answer is again C. Are there any questions about this problem? All right, then let's take a look at the final question. So a 5-legged Martian has a drawer full of socks, each of which is red, white, or blue. And there are at least 5 socks of each color. The Martian pulls out one sock at a time without looking. How many socks must the Martian remove from the drawer? Be certain there will be 5 socks of the same color. A6, B9, C12, D13, E15. Um, what do we give for this question? Okay. It says D. Does anyone else have any ideas about how to solve this? Okay, that's fine. For this question, it's really just a reasoning question, right? Because I mean, you think about what's the worst thing that can happen. And the worst thing that can happen is that the Martian could pull out 4 socks. Oh shoot. 4 red socks, 4 white socks, and 4 blue socks, right? He'll pull out 12 socks and it's 4 red, 4 blue, 4 white. That's the worst case scenario. In that case, you just have to pull out one more sock, and no matter what sock it is, it will be one of R, W, or B, and so will satisfy the requirement that there has to be 5 socks of the same color. And so it's just 3 times 4 plus 1, and the answer is 13. So the answer is C. Are there any questions about this? It's honestly a really simple question, actually. You just think about what's the worst case scenario. All right, well then, if we don't have any questions, this we are out of time. So thank you for coming and have a great rest of your weekend.